What is going on, everybody? It is me, it is the original gamer ogStevieStrow, and we are back for yet another exciting chapter in programming in BASIC on the Tandy color computer. And today, boys and girls, we are now up to chapter 26. And if you just followed my last video, which was chapter 24, you might say to yourself, well, what happened to chapter 25? And the answer is easy. I have skipped chapter 25 because chapter 25 is dealing with saving to cassettes, which I have zero interest in, and hopefully you do as well, because you know what? It's the 21st century. We haven't used cassettes since the 80s. Technically, we haven't used Cocos since the 80s, unless you're crazy like some of us and you still have, or you've picked it back up again, but I digest. Managing numbers. Very cool concept, some fun stuff to do in here. I've come up with a couple of just slight variations to what's in the book. No custom demos here, all straight from the book, but you know, hopefully a little bit of value added explanations on what's going on here. So, chapter 26, managing numbers. Have you ever tried to write a program to handle much information? If so, you'll be glad to know that BASIC has an easy to manage way to keep track of information. And so now we're seeing an example here of some election numbers. Assume, for example, you want to write a program that lets you manage this information. There are 14 different districts, and each of these districts received a certain number of votes for candidate A. And it says, now up until now you've used variables to store information in memory. For example, you could say, well, A equals 143 for candidate 1, B equals 215 for candidate 2, C equals 125 for candidate 3, and so on. But it says that there's actually a better way to do this, and you could say A parentheses 1 equals 143, and A parentheses 2 equals 215, and A parentheses 3 equals 125, and it says each of the above variables has a subscript, which is these numbers in parentheses. So our 1, our 2, our 3 in parentheses. Other than how they use the subscript, these variables work the same way as any other variables. To see for yourself, type in both of these lines. For example, it'll say print A, B, C, and then print, if we had typed in all these numbers into memory, which I hadn't bothered, and then I printed them out, we would see that they were exactly the same. We'd see there were 143, 215, and 125. Hut. But we're not going to do that. So what we're looking at here is kind of sort of a hybrid of the old way and the new way in the program. So the first 3 lines have a bunch of data statements here that read in all 14 numbers that happen to be the votes for each of those 14 districts. And then we read in each number as a separate variable. So the first number will be read in as A, the second number will be read in as B, third number will be read in as C, and so forth. So not the most efficient way to do this. And then we've got a whole routine here that says, all right, well, I'm going to ask you to enter a district. I'm going to take that district number, and depending on what you picked, if you picked 1, I'm going to print the value of variable A, which is 143. If you print 2, if you pick 2, I'm going to say print B, which is 215, and so on. So you can see here, this program is long and chunky, right? That was my nickname in high school too, long and chunky. So yeah, this is you know, it's bloated code. So let's see what it looks like on the Coco. You can see here I've typed all that stuff in here. Here's the first part of the program. Here I've got the data. I've got the reading of the data into variables. I've got the inputting. I've fixed the logic a little bit where I've also checked to see if not only if you enter a number greater than 14, but if you enter a number less than 1, so if you enter 0 or -1. And then it goes on, and it then goes through all this long-winded logic to figure out what, if you type this, then we're going to print that, and so on. Now I also cheated a little bit too, because after each time here it was actually printing out the word vote. So it says you then print A semicolon quote votes quote. And so since I was using the word votes a whole bunch of different times, I kind of took a shortcut here. I stuck that into a variable v string for votes, and now I am just having to use less bytes of memory here by not having to write out the word votes so many different times. And so what's happening and what will hopefully happen for anybody who starts to write programs and uses computers is over time you start to think more efficiently because the computer trains your brain to do that. And so sometimes now when I'm looking at these programs in the book, I'm already taking a few shortcuts to how they're having me do things just because it just makes sense to do that. So let's go ahead and run this program right now.
Hi, this is John Robbs. I'm at the Cocoa Fest here with StevieStrow, the original gamer, and we're having a great time geeking out on 30-year-old hardware. Having fun.
And so when I run the program, it says, well, what district do you want? If I print in District 1, it'll tell me how many votes it got for that one. If I put in District 2, it'll tell me how many votes. If I put in 0, it's not doing anything. If I put in -1, it won't do anything. And if I put in anything greater than 14, it won't do anything. But if I just pick a random number, I'll see how many votes got in there. And so part of this program is still the data. But the other part of the program is a very long-winded, very verbose way of having to deal with this data. So the next thing we're going to do is we're going to learn a little bit more shorter version of how that works. And so you can see that this program here originally started on line 10 and went down to line 220. But when we shorten it, we now have much less code here, because now instead of reading in as 14 separate variables, we're creating a dim, we're creating an array, a dimension, and then we're going to say, well, we're going to dim 14 different variables for x equals 1 to 14, read in AX. So we have A1, A2, A3, A4, and those end up being the 14 numbers here read into an array. And then at this point here, I am then going to just print out, depending on what you picked. If you picked 1, I'll print A1. If you print 2, I'll print A2. If you picked 3, you know, so on and so forth. So that should go a little smoother. So here's the shorter version of that program, and you can see here that we definitely have a lot less lines of code, but we're going to effectively achieve the same results here. So when I run this, if I pick a district, you can see here that as I keep picking my districts, it's going to then show me the numbers for those districts. So this is taking the concept of the array, and I'm loading in 14 different variables, but I'm loading them into A1, A2, A3, A4, A5 into an array. I did something similar like this when I set up my fonts, where I read all my font data into string arrays. So you can read in string arrays and you can read in numeric arrays as well. Arrays are always defined by the dim command, and the dim command is telling your computer how much memory to block off to store these things in here. It says program number 1 was cumbersome to write, and program number 2 is short and simple. Enter and run program 2, and here's how it works. And I kind of just showed you how it works. And so now it's also adding some more things here. So now it's the next enhancement to program 2 was to add the question here of, okay, well, here's how many votes this district has, but would you like to add to that? So this is almost like how the Russians hacked our election. So we've now added a few more lines here where not only are we going to tell you how many votes a particular district got, but it's going to come in here and say, well, would you like to add to that? And I've also kind of tweaked this code a little tiny bit because it's looking for you to enter in exactly no if you don't want to, but I got kind of fancy here and I said, well, you could press N for no, you could type out NO for no, you can type in anything that starts with the letter N. I'm just going to look at the first letter here to give you some more options here. So let's see what this looks like now when we run it. Pick a district. District 9, good movie. Okay, District 9 got 318 votes. Would you like to add to this? So basically, unless I type in N, anything else is a yes. So let me just hit, like I'll hit frickin' W, right? Okay, so because it's not looking for anything but an N. How many votes would you like to add to District 9? It's at 318. We'll add 2. And then boom, total votes for District 9 is now 320. And so now if I type in District 9 again, it should show me, because I've actually updated that variable in memory, it should show me that it has this. Do you want to add any more votes? I'm going to hit N for no. So now we've basically added a little bit of extra stuff here that not only lets you view one of these district array variables in memory, but it has the cool value added feature of saying, hey, you know what, you want to hack the election and you want to throw some more votes in here for your favorite candidate? Why the hell not? You know, America. All right, so, but we're not done. Wait, how much more would you pay? Because now they've even added another section here that says, all right, well, let's start things off by saying, well, would you like to see what all of the voting totals are? And then we'll get into the rest of that kind of stuff where you can change things. So the program is going to start off with a new prompt when we add all of that good stuff in. So here's some of the new stuff here. We're going to see a new prompt at the beginning that's going to say, do you want to see all of the votes? And so I modified this one just a little tiny bit, where if you press anything that starts with the letter Y for yes, so you don't have to type in YES, you could type in Y, you could type in yo, you could type in yellow, whatever. Anything that starts with Y, if the first letter of whatever you type in starts with Y, then it's going to go sub line 110, which is a new little routine. And little routine is now going to print out the name district in one column and the word votes in another, and we're going to count from 1 to 14. We're going to print that number, so we're going to print 1 for district 1, and then we're going to print the value of A1, which is how many votes that one got, and an A2 and an A3, all the way down to 14. So let's take a look at that. Do you want to see all of the totals? Why the hell not? Why the hell not? Right? Because all it's going to look at is the Y. And then here we go. It's printed out all 14 districts. District 9 has 318 votes. Let's go ahead and go back to District 9. Would you like to add to this? Yes. How many more votes? 2. Now we're at District 9's up to 320. If I want to verify that and I type in 9 again, boom, it's got 9 votes, right? So you can see here that as we're doing this, we're getting, you know, we're looking through memory here. So kind of cool, right? And what this is really showing us is that we have read some numeric values into a bunch of array variables. Currently there's 14, so there's A1, A2, all the way up to A14. And we can print out the values of those variables. So basically printing them is showing us what number is being held inside that memory location. And then on top of that, it even gave us the kind of fancy feature saying, well, right now that number is 12. Would you like to add to it? Sure, let's supersize that. Let me add an 8 to that, and it's going to say, okay, well, now it's 20. So, and you can just kind of keep messing around and keep hacking your own elections, because America. Now, we're not done, because now we're going to take it to a whole nother level, and we're going to read in 2 sets of candidates. So we're going to read in 14 numbers. We're going to read in votes for candidate A, and then we're going to read in the number of votes for candidate B, and we're going to compare and contrast these candidates and see who's getting the more votes. And from the quick glance here, it's kind of looking like candidate B is winning by a landslide right now. And so as we continue to go through the program, and I've tweaked this program just a wee little bit, but the first 3 lines here are the so 10, 20, and 30 are the 14 numbers for candidate A's votes. 40, 50, 60 are the 14 numbers for candidate B's votes. Line 70 is now dimming for candidate A and B. Line 80 says I'm going to read in 14 variables for A. Line 110 says I'm going to read in 14 variables for B. And then line 40 then asks you for a district number, checks a little tiny bit to check the validity of your district to see if you're going out of range. I've kind of tweaked that a little tiny bit. And then it got kind of, to me, I want to say fancy / complicated, because it's going to say, all right, well, now that you've picked District 9, well, do you want to see candidate A's numbers, or do you want to see candidate B number? And I just thought that was like a layer of complexity that I just didn't feel like dealing with. So what I decided to do was, when you picked a district, it's going to automatically show you both numbers at once. I've also added in, I think I've added in the feature where if you try to enter an invalid number, I've added a couple of little beep sounds to let you know that that's a no-no. I'm just kind of carrying over from the chapter I just did on the play command. So if memory serves, I think I did that. So let's find out. Yeah, so what we see here is we've got all of our array data, and so this is how we're dimming out candidate A's 14 district votes and candidate B. Then I read in from 1 to 14, I read A 14 times. From 1 to 14, I read B 14 times. I then ask you for your district number. I then check to see, well, if it's less than 1, meaning if it's 0 or a negative number, or if it's greater than 14. Then I'm going to play a low frequency tone, a little, hey, idiot, beep, and then let it go back. And then if you do pick a candidate, or if you do pick a district, rather than saying, would you like me to print candidate A or candidate B, I print the column heading of candidate A and B, and then I print both numbers. So yeah, I don't care which one you want to see. You're going to see them both because America. So let's go ahead and try out this program here right now and see how it works. All right, so pick a district. What happens if I What happens if I pick a pickled peckers? What happens if I pick district 0? You hear that? If I have 15, if I just hit enter, it's basically giving me an idiot beep. Hey, idiot. Doesn't work. All right, so let's pick our good old district 9. Okay, and when you do that, I've actually added a little tiny beep sound. Why not? It doesn't cost anything extra, right? So in district 9, candidate A got 318 votes and candidate B got 420. Woo! So let's pick another one. Let's go to district 3. Okay, 125 and 430. So you can kind of see where we're going with this one, right? 10, 14. So it's a little variation on what was in the book, but you kind of get the idea here. And then here's the little program. This is basically minor modifications to what's in the book, just a little bit of a StevieStrow touch to it. Since I figured we were messing with the play command, I'll add some play stuff in here. So that is that. And so now we're getting into some stuff here that we're calling deal the cards. And so there's a couple of different card programs. And so the first one that it's going to have us run is going to show us that, well, we can do a for next loop and 52 times and pick a random number between 1 and 52. But what we're going to see if we do that is we are going to see that when you do that, you're going to see a lot of duplicate numbers. So let's take a look at that theory right now. If we look at the first example, it says, all right, for x equals 1 to 52, we're going to pick a random card number, which is between a random number between 1 and 52, and then we're going to print out that card number. But when we run it, we're going to see here that we're going to get some duplicates, okay? So because all I'm doing is I'm picking a random number and I'm not comparing that number to if the number has been picked already. And I'm not going to sit here and try to compare all of these, but I'm pretty sure, like here's 2 4s, right? So in a normal deck of cards, you wouldn't have 2 4s, right? So this logic here is basically saying pick a random number 52 times, but some of those numbers might be duplicates. So we get a little bit more crazy with the cheese whiz here, and now we're creating an array. And so now we're going to dim the letter T, and we're going to create 52 slots for the letter T. We're then going to count from 1 to 52, and we're going to plug those into T. So T1 will be 1, T2 will be 2, all the way up to 52. Now we're going to go down to line 40, and we're going to now start to do a loop from 1 to 52 again. But then we're going to say, all right, well, now we're going to pick a random card that says number 52. And then this is the weird thing. Now I'm going to go into line 60 and say, all right, well, if I'm on 1 and T1 equals 0, then I'm going to go back to line 50 and pick another one. And right now, none of them will equal 0 when we first start because they all are be like 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's going on here? Hold on, I'm trying to pick up my cat because my cat's in here whining at me. What's going to happen here is it's going through the count of 1 to 52. It's picking a random number and then it's comparing that number to one of the variables. And the first time it picks it, if that number is not in use, it's going to say, okay, that's good. I'm going to set that number now to 0, which says now that card has been played. And so this is a little logic check here that's going to check to see if the number I've picked is equal to a card in memory that's been used yet. And if it hasn't, I'm going to use it. If it has been used, I'm going to mark it as used. Then I'm going to print that number on the screen, and then I'm going to go through the loop. And what we're going to see here as we run this is that the further through the deck I get, the longer it's going to take for it to make these decisions. And so here is the random numbers, and it's starting to slow down now. But what we're going to see is that there will be a total of 52 numbers, and none of these numbers are going to be repeating because of the kind of hard to follow the logic here. I kind of get it. I'm trying to explain it, but I'm not sure I completely understand how to explain it, but I understand what it's doing. So there's a little bit of logic in here that's basically saying, as I pick these random numbers, I'm going to compare them against the numbers in this previous array, and this is going to help me track when a number has been used, because T1 is 1, T2 is 2, T3 is 3. And so as I'm going through my loop, I'm going to basically be checking things off and making sure I don't repeat these numbers. That's what it's doing. If you can't follow it, take my word for it. And then there was one more thing that we added to the end of this. And then the last thing that we added was the fact that these lines here were the ones that check to see if a card was in use, which I just showed you. And then it adds a few more lines here where I am now going to create another array that's called D for like cards that have been dealt. And as I'm dealing these cards, I'm going to stick each one of these in this array here. And so the first time we had an array of numbers, they were all sequential. So we had card 1 was 1, card 2 was 2, card 3 was 3, and so forth. So that was kind of a linear sequential array of numbers. We then started picking things randomly, and as we were randomizing these cards, we started crossing them off the list to make sure we didn't duplicate that. But as we're picking these things randomly, we're now going to take those random numbers and stick them in a new array that's called D for dealt 1, dealt 2, dealt 3. And so as I pick the random numbers, card dealt 1 is going to be random. It's not going to be sequential. 2 will be the second random number I picked, 3 will be the third random number I picked, and so on and so forth. And so this is mostly that program right now. That program kind of ended here, but this is kind of where the program was figuring out is the card in use or not. But now we introduce a new line here. We introduce this line here of dealt card. So when we're going through our for next loop here, if we're on X is 1, so dealt card 1 is going to be whatever random number we picked, and so on. But now what I'm printing is the dealt card variable, which is the same as this, but it's being stored in here for a reason, because I'm also now generating some sound. I'm generating some sound as it's going through here. So I started off by clearing the screen and printing something on the screen here, shuffling the deck, right? This is where I dimmed my cards. This is where I dimmed my dealt cards, right? So and then these extra lines that we added here, we're basically sticking in as we're generating these random numbers, we start sticking them in the new array. And so we're creating a new array of numbers based on how they're randomly picked from the deck, and we're putting them in a new location in memory, which is what we're actually going to display on the screen. I also generated some random sounds. So I'm picking a random octave and a random note, just kind of a callback to the play command we just covered, and then I'm playing the octave plus the string variable of that random number. I'm doing a length 48, so it's a relatively fast note, and then I'm playing the number of the putting n for number and typing in the string value of that random number. So I'm going to generate one of 60 random notes that are going to play rather quickly as I'm picking these random cards. So as it's picking cards, it's going to be like like computer noise. And then the last thing the chapter asked us to do as far as the DIY thing, or DIY, do it yourself, was, all right, well, now that you've changed this, how can you take this information and show us what your hand would have been? Like, what if we were playing 5-card poker, draw, whatever, what were the first 5 cards that were drawn, because that's your hand. So I then printed a little message here saying, okay, well, here's your hand. And then I went back and I said, okay, for x equals 1 to 5, so that's 1, 2, 3, 4, 5. That's the first 5 cards that were randomly drawn, which are stored into D1, D2, D3, D4, D5, the first 5 cards drawn. And then as I'm printing out those numbers, I then also make a little bit of a sound based on where x is. So the sound kind of gradually gets a little tiny bit higher. And then you're going to see what Willis is talking about here in just a second. So shuffling the deck, random sounds. And then here's your hand. So you notice here that the first 5 numbers are 29, 30, 43, 45. What's my hand? 29, 30, 43, 45, 20, right? So these were stored in a new array variable called D1, D2, D3, D4, D5. Technically there's 52 of these Ds, but the D variable now stored these numbers in the order in which they were drawn. So they were drawn randomly, and I'm now sticking these random numbers in a sequential order. So this is D1, this is D2, this is D3, this is D4, this is D5, and then that's the hand that was dealt to me. These are all 52 of the numbers. None of them are repeated because of the little logic checking that we went through to make sure that we mark them off as they're issued so we don't issue them again. And that was the program. That was the chapter. And they are using dim to create a dimensional array, right? So it's becoming kind of like a multi-dimensional situation here where it's the variable with these subsets, so A1, A2, A3, and A4. So 2 concepts, dim and array, were covered here, and this is going to be useful in a lot of different ways, because something I used to do in the past was I used to use these things to keep my high scores. And so that was a very common thing in arcade games and in video games, where you had like a top 5 or a top 10 set of scores. Like if you're lucky, you had the name or the initials and the score, so you saw kind of a leaderboard of who was there. Well, those are all stored in arrays. So you've got high score 1 for first place, high score 2 for second place, all the way down to 10th place. And so not only do they need to be stored in memory in these arrays and these variables, but when new scores come in, that score needs to be compared against the other scores. And then sometimes once you've figured out where you are, then you have to resort everything to, you know, depending on what my score is. Am I in first place? Am I in 5th place? So I got to go through all 10 numbers and compare them. And once I figure out where I am, I have to then resort all the numbers, and then, you know, I might rank somewhere in that top 10. So there's a little bit of math and a little bit of logic in there to do a high score table and to sort that table as new high scores come in. And so that's something that we'll get to at some point in time. I don't exactly remember the routine I wrote to do that. It's been so long, but hopefully it'll come back to me, or I'll just figure it out again. So there you have it, folks. Chapter 26 in the bag, dealing with number arrays in memory. Not bad, not bad, not bad. We got through this. Nobody was hurt. Nobody was harmed during the creation of this video. So chapter 26 is out of here, and I am out of here. I'm the original gamer, StevieStrow. Don't forget to give this video a like, to subscribe to my channel, to share with your friends. If you like retro like I like retro, not only should you be watching all the videos on my channel, but you should probably also head over to my website and check out some of the cool merchandise, color computer gameplay DVDs, and cool t-shirts and coffee mugs and stuff like that. Show your love by grabbing a piece of merchandise, and we would appreciate it. Until the next time, we'll catch you all later. Coco forever. Keep on coding, keep on basicing, and all that good stuff. Bye bye, everybody.
Hi, this is Randy Weaver, and you're watching The Original Gamer, StevieStrow.